Hi everyone, this is Algebra 2, Lesson 1-4, and we'll be dealing with slope-intercept form, possibly standard form. But as always, let's refresh our memory here. Whereas slope-intercept form, we saw this last time, is y equals mx plus b. And in a different color here, the m is my slope, the b is my y-intercept, and so that's going to be 0, comma b. So the x is 0, the b is my y, hence y-intercept. And we'll see an example of that in a little bit. So number 1 says, writing an equation of a line given its slope and y-intercept, write an equation in slope-intercept form. So the slope-intercept form is y equals mx plus b. And that's what I have here. I have a bunch of information. So the slope is -2/5. That's my m. And the y-intercept is 0, comma, -4. This is x, comma, y. Meaning the b of this is -4. -4 is the b. So I have y equals my slope to -2/5 minus, -2/5 x, excuse me, minus my b, which is 4. And there you have it. Now I have y equals mx plus b. Don't get too confused with the plus b portion. You can always do plus and then -4 in parentheses, and that would be fine as well. Try the one on the right-hand side. Number 2, writing an equation in slope-intercept form, which is y equals mx plus b, given the slope and a point, write an equation in slope-intercept form for each line. So let's see what we kind of have here at the beginning. I know I want it in y equals mx plus b form. A line passes through a point, x, comma, y, and has a slope of -5/2. That's my m. So unfortunately, I don't have 0, comma, y, and so what we can do is plug the information that we have into our equation y equals mx plus b, and we can find our y. So let's see what that looks like. I have y equals mx plus b. I don't know my b, but what I do know is my y is -8. My m is -5/2. My x is 10 plus b, which is just a variable. Now, don't freak out, is that you have already solved in 1-1 equations with a variable on one side. You just commonly use x, right? Or you commonly use m, b, a, whatever variable. Here we just have the variable b. So we have -8 equals, and we can do some cross cancellation here. It's 1, 5. So what is -5 times 5? That's -25 plus b. We can plus 25 to both sides. So 17 equals b. Now I know my y. So now it says write an equation in slope-intercept form. Well, I know y equals, my slope is -5/2x plus 17. There we go. That's slope-intercept form. Try the one on the right-hand side. Writing an equation of a line given the y-intercept and another point. Write an equation in slope-intercept form. So first thing I like to do is I see that there's 2 points and they're signified in red on here. And what I like to do is put it in x, comma, y form, or just point. So here is a x of 0 and then a y of 4. Okay. And then down here, I have an x of 1, 2, 3, 4, 5. So this is negative 5. And this is 1, 2, 3, 4, 5, 6, negative 5, comma 6. So there's two ways of finding slope, is that we can use these 2 points of negative 5, comma negative 6, and do the y2 minus y1 over x2 minus x1. We could do that. Or another way you can do is just kind of find the slope yourself by doing rise over run. So if I went up 1, 2, and over 1, it lands perfectly on the line. 1, 2, over 1 lands perfectly on the line. 1, 2, over 1, and et cetera, it will take you to this point. So I mean, we're able to find our slope. So I went up 2 and then over 1 positive. So my m equals rise over run, which is just 2. My m equals 2. And it wants us to put this in slope-intercept form. Well, I have my y-intercept right here, 0, 4. That tells me my y-intercept. If this helps with the connection, let me phrase it this way. This is telling me, this number, where the point intercepts. Like if you think football, you're an interception. It intercepts at the 4 here. So wherever the point is directly on the vertical axis of y, that's what your b is going to be. So I have y equals my slope, 2, and then x plus 4. And that is that. So again, there's multiple ways of finding slope. I could find 2 points along that line and then do the y2 minus y1, x2 minus x1 to find slope, which is fine. Or you could just do rise over run like we did and we drew it out, where I went up 2 over 1, up 2 over 1, and that's my slope there. So there's a few different ways that you can do this, but go ahead and try the one on the right-hand side on your own. This one says, writing the equation of the line through 2 given points. Write an equation in slope-intercept form for each line. So I want to put it in y equals mx plus b. And if you're wondering why I write this out so many times, is because that helps me memorize slope-intercept formula. So what do we have here? Well, let's first, what I like to do is plot the points. The points are already plotted, but let's go ahead and write what the x and y are. 6, 3. This one looks like it's negative 4, 5, I believe. Negative 4, 5. I'm going to write it above it. Negative 4, 5. Okay. And again, that is our x, y, and then x, y, in case you were curious. And I want to see if I can find the slope by doing rise over run. Again, there's 2 options here. We can do rise over run, or we can do y2 minus y1, x2 minus x1. So to find slope, maybe it'll be helpful if I wrote this out. You can count the rise over run, or use the slope formula. And that is y2 minus y1 over x2 minus x1. You choose whatever is easy for you. Some methods will work better than others. If we did count, I could see that we're going down 2, right? Because to do the rise, you're either going up or down. So we're going down 2, and then I'm running quite far here. I'm running 10. So notice I'm going down which is why I have a negative 2, and then I'm going in a positive direction along the x-axis through 10. So my m is, my rise is negative 2, my run is 10, which equals negative 1/5. Negative 1/5. Now, notice where my point crosses the y-intercept here is not directly on 4. So I just can't say that my y equals negative 1/5 x plus 4 because it doesn't lie exactly at 4. So I have to find my b. I have to find my b. How can I do that is I can just use an x and y point, or just choose a point and solve for b. So I'm going to use this point here, 6, 3. So my y is 3. My slope is negative 1/5. My x is 6, and then I have plus b, because that's what I'm trying to find. I don't know what that is yet. 3 equals negative 1/5 times 6 is just negative 6/5 plus b plus 6/5. Actually, I should do this so it doesn't get messy here. Plus 6/5. I get 6/5 plus 3/1 equals b. I want a common denominator. I need to times this by 5 times that by 5. I'm sorry, everything's getting so tiny here. I'm going to then move everything over here. I get 6/5 plus 15/5 equals b. That is 21/5, or in other words, 4 1/2, or 4 1/5. Excuse me. 4 1/5. So I just took an improper fraction and converted it. Equals b. So this is very messy, and I hope you could forgive me here, but we have y equals negative 1/5, which was our slope, and then plus 21/5, or you could put 4 1/5 if you want. I'm going to put 21/5. So our y-intercept is 0, 4 1/5, or you can put it as 21/5, whatever works for you. And there we have it. Oh, you know what? There is a little mistake here. I forgot the x. So hopefully you were shouting at me, put the x, put the x, put the x. Negative 1/5 x plus 21/5. That is a good point to always check your work at the very end so you don't leave anything out. Let's move on to number 6. It says writing the equations of and horizontal lines through a given point. Write the equation for the vertical line passing through 5, 1. So sometimes it helps to actually just draw this. It says write the equation, but let me just draw it so you can visually see. So this is 1, 2, 3, 4, 5. 1, 2, just to give an example. So this is my x, and that's my y point. So my x is 1, 2, 3, 4, 5, and then up 1. It's right here. So what this is saying is that my line here is it's telling me it's vertical, right? So this is a vertical line. Ooh, pretend it's going through that point. Make it just bigger. If the point is going through that, then my equation is x equals 5. If it's vertical, you'll have x equals something. What if it's horizontal then? What if it's horizontal? Well, let's draw it. Where I have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Again, that's my y, my x-axis. And then the point is x, comma y, so it's 1, 2, 3, 4, 5, and then up 1. So same point, but it's saying write an equation for the horizontal line, meaning it's going like this. Sorry, it's not a perfect line. But the line cuts through at 0, 1 here. So if it's 0, 1, our y equals 1. So notice a difference here. This one up at the top is our x-axis, right? And it's cutting through, let's see if I do a different color. It's cutting through the x-axis right here. It's not the perfect color, maybe green. It's cutting through the x-axis right here at 0, at 5, 0. That's why our x equals 5. So that's x, y. But notice down here, it's crossing right here. So this is our x, y. Our y equals 1. So it's whatever the axis is that it crosses. So at the top one, it's crossing at 5, and at the bottom one here, it's crossing at 1. So I hope you find that helpful. If there's any confusions with this, this is why we have class time to cover multiple examples of this and practice even more. But for now, try to take that logic and reasoning and apply it to the one on the right-hand side. Let's look at number 6 here. Finding slopes of lines parallel and perpendicular to a line given in slope-intercept form. So we have y equals mx plus b form right there. What is the slope of a line parallel to this line? So a little bit of knowledge here, and kind of something that will help you just remember. Know that parallel lines have the same slope. What I mean by that is if we were to draw and say that this isn't going to be to scale or anything, but say we were to draw this slope, it starts at 6, right? Our y-intercept, 0, 6, 1, 2, 3, 4, 5, 6, so a point there. And our slope is 5, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4. So our line is going to look like this, right? And then if I had a parallel line to that, just say theoretically, our slopes would be the exact same. I would go down over, but hopefully you are able to visualize it. I'm sorry, it's not perfect. But again, what you need to know is that on parallel lines, you'll have the same slope. So my slope is right here. This is my m, so negative 5/4. Again, it's not 5/4 x, it's only 5/4, negative 5/4. What about perpendicular lines? What is the slope of a line perpendicular to this line? Well, when lines are perpendicular, or perpendicular lines, they have opposite, or in other words, reciprocal slopes. Forgive me for my penmanship, it is kind of hard writing on the iPad here. But reciprocal means you flip the slope and then change the sign. So before we had negative 5/4, well, the reciprocal is 4/5. And what that would do, if we had to draw this, is before we had a slope of negative 5/4, but what would happen is if you flipped it and then you crossed it, it would create a 90-degree angle. So say we did this, and then we flipped it, just say theoretically. It's not going to be perfect, but it created a 90-degree angle, and usually that 90 degrees is actually done in red. So I'm just going to kind of scribble some things here. But a perpendicular line creates a 90-degree angle. So if you ever need to plot your points and have them perpendicular to each other, meaning they intersect one another, it will create a 90-degree angle, and you're able to check your work through that. So try this one on the right-hand side. Hopefully through this lesson I'm not going too fast, but I'm also trying to make these lessons short for you all so that you're not doing too much of mathematics at home and you're able to spend time on other subjects as well. But this is also predicated on that when you come to the classroom, you are able to ask me to go over an example from the notes where you need more practice on, and I'm more than happy to do that for you. Number 7, writing equations of parallel lines and perpendicular to a given line through a point. Okay, so consider the line y equals negative 6/7 x minus 3. So what is the slope of a parallel line to this, what is the equation of a line parallel to this line and passes through -7 and 5? Well, if this is parallel, we just said that parallel lines have the same slope, 6,7. Now all we need to do then is just plug in our x and y to the formula, and we'll be able to figure out our other line that passes through it. So I have my y, which is 5. Okay, I got that from up there, equals -6/7, because it's parallel, I have the same slope, times my x, which is -7, plus b. That gives me 5. Those 7's cancel, the -7's. So I'm just left with 6 plus b. You minus 6 from both sides, you get -1 equals b. Now, since lines are parallel, I'm going to have the same slope. And then I have my b, and there you have it. So if we were to put y equals -6/7 x minus 3, and we drew that line, and then we drew this line down here, you'll see that those lines will be exactly parallel to each other. Well, what about perpendicular lines? Remember that we said the slope is the reciprocal, and we're using the same formula we had at the top. So my slope is the opposite of -6/7, which is 7/6. I have my x and my y there, so we're going to do the exact same thing. I have my y, which is 5, equals my slope 7/6. My -7 is my x, and well, we don't know the b for right now. For this, 5 equals, we are multiplying across, -7. It's basically 7/1, right? Same thing. We get -49/6 plus b. We have to add 49/6 to both sides. I get 49/6 plus 5/1 equals b. I need to find a common denominator, multiply by 6. I'm gonna move this up here. I get 49/6 plus 30/6 equals b. That's 79/6 equals b. So I'm left with y equals 7/6 plus 79/6. Woof. Not a fun-looking slope-intercept form example, but if you were to plot the line that we were given up at the top and then the new line that we found here, you would see that they would intersect each other and create a 90-degree angle. So go ahead and try the one on the right on your own. Okay, looking at number 8, application problem with a linear function, finding a coordinate given 2 points. So we're going to be taking the same idea that we did before. We're going to probably need to find slope, plug it into y-intercept, or excuse me, slope-intercept form, and then go ahead and solve for y. But let's see what we have here. Suppose that the height in centimeters of a candle is a linear function of the amount of time in hours it has been burning. After 5 hours of burning, a candle has a height of 24.5 centimeters. After 22 hours of burning, it has a height of 22.8 centimeters. What is the height of the candle after 19 hours? So it seems like a lot, but let's try to just break down what we have first here. So I see that along the y-axis here at the top, I have the candle height, so that's going to be my y. And then along my x-axis, I have burning time in hours. Okay, so that's going to kind of help me formulate my x comma y points. And these points are going to lie along this linear line right here. So there's going to be points. And they gave us the information, right? They said here that 5 hours, so where can I put this? Let's do 5 hours, comma, and I know 5 is x, right? Because it says 5 hours here. Hours is my x. So 5 hours, hours down here. A candle has a height. I know height is my y because this is along my y-axis, and it says 24, 24.5. So that's 1 point. And then it says after 22 hours, so again, hours is my x. I have a height of 22.8. I know that's my y because it's in also centimeters, and it says height right here. And that's another point. So if we were to plot these, I'm going to kind of just erase these little points here. If we were to plot these points on our line here, we're just going to kind of guess where they're at. But I would say maybe 5, 24.5 would probably be right there, right? Because this would be like 1, 2, 3, and so on and so forth, right? We'll just say that we go by 2s here. 2, 4, 6, so on and so forth, all the way to, say, 22. We'll say 22's down here then. So this is 22, 22.8. I'm sorry it's small, it doesn't really matter. But I just wanted you to visualize that they're giving us points along this linear line here within the paragraph. And so, again, I have 2 points, and this should be very familiar or look very similar to what I had before, where I was able to find my slope of m, and the formula was y2 minus y1, x2 minus x1. So let's go ahead and just label these real quick. I'm going to label this my, deleted some stuff here. Still 5. So this is going to be my x1, y1, my x2, y2. And I'll keep it in red, why not? So let's do this. I'm going to bring this down here. My m equals my y2, which is 22.8, minus my y1, 24.5, all over my x2, which is 22, minus my x1, which is 5. And if you did the numerator, you should get negative 1.7 all over 17. And that just comes down to a negative slope of 0.1. So now that we have that, and we have our slope, I have points. I could take these points and I could choose either one. I can either choose this top one, or I can choose that bottom one, the 22, 22.8, and just plug that into slope-intercept form. So I'm going to just choose the 5, 24.5. I'm just going to choose that point. You can choose either one. You'll come to the same answer as I do. My y is 24.5 equals my slope negative 0.1. My x is 5, right? My 5 is right there, plus b. We don't know what that is right now. So let's solve this. We're going to add, well, let's solve this real quick. Or should I say simplify it? Negative 0.1 times 5 is just negative 0.5 plus b. We're going to add 0.5 to both sides. Now we get 25 equals b. 25 equals b. Well, what was our original slope-intercept form then, based on b? It is y equals negative 0.1x plus 25. Now I know what the b is. So now the line there, the line that you have that's in purple, let me draw it in for you in red. This line right here, that is negative 0.1x plus 25. That means this point right here is 0, 25. Why is that? Because again, this is my y-intercept, and it lies on the y-axis there. But the question is, back up the top, what is the height of the candle after 19 hours? Well, what does that 19 hours represent? Again, what is that 19 hours represent? Meaning, what is the variable? What is y at x equals 19 hours? Question mark. Sorry, that is extremely messy. So what is y at 19 hours? Meaning, if I rephrased that, what is the candle height in centimeters at 19 hours? Or how, the candle's been burning 19 hours, what is the height of the candle? That's all that's saying right there. So don't get too confused by the way the language is being worded. So let's figure that out. We know what x is because they told us 19. So I'm trying to figure out what y is. My slope is that times 19 hours plus 25. This equals negative 1.9 plus 25. So my y is going to equal 23.1 centimeters. 23.1 centimeters. So if I plotted that line, let's see if I can find a different color here. Maybe purple might show up better. This is going to be 19, 23.1. That's going to be that point. I'm just going to guess kind of where it would be at. This is going to be way off, so forgive me, but I'm going to say like maybe right. Let's see if it'll let me do it. I'm going to say right there. That it's not, obviously it's not correct, the exact point where it would be at. There's a lot of human error where I put the tally marks and everything of that nature. But hopefully you understand and are able to grasp what we're looking for here. There's a lot of steps. I would highly recommend that you try to do this whole problem on the left-hand side on your own for practice. And then just see if you could just do it based off, almost off memory. And then try the one on the right-hand side. Do it however you please, but there is a lot that goes into this, and just doing it and copying what I did doesn't necessarily mean that you understood it. And so you need to kind of test yourself and print this document as many times as you would like, and then do practice problems, the same problem on your own, so that you see the skills that are going into it and hopefully are making connections to what we're learning, so that when you try the one on the right-hand side, you're able to do it, again, based off the skills and procedural fluency that I'm showing you on the left-hand side. So that is going to be the conclusion of Algebra 2 Lesson 1-4. Good luck, everyone.